In this video, I'm going to cover finding the absolute extrema, so the absolute maximum, absolute minimum of a given function on a given closed interval. So we have this function, 2x cubed plus 21x squared plus 36x on the interval from -7 to 7. So the way this works is we first need to compute any critical points that this function has on this interval. So the derivative of this function would be, so 2x cubed would be 2 times the derivative of x cubed, which is 3x squared. So I get 2 times 3, so 6x squared plus 21 times the derivative of x squared, which is 2x. So I have 21 times 2, which is 42x, plus the derivative of 36x, which is just 36. Now, the critical points are wherever derivative is equal to 0. So I would set this equals 0, but notice you can factor a 6 out of every term. So if I do that, then I have x squared plus 42 divided by 6 is 7, so 7x. And then 36 divided by 6 is 6. So this is 0 if and only if this is equal to 0. So this can be factored. So I need two numbers whose product is 6 and whose sum is 7. So that would be 1 and 6. So x plus 1 and x plus 6. So now I can set both of these equal to 0. So if x plus 1 is 0, that means x is equal to minus 1. And then x plus 6 is equal to 0, so x is equal to minus 6. So these are my two critical points. Now, in this case, the two critical points are inside the interval, from -7 to 7. So I need to examine both of them. If any are not inside the interval, you must exclude them, because they cannot be considered as a candidate for the absolute max or absolute min on an interval when they're not even inside that interval. So watch out for that. Check. So in this case, it turned out to be moot, but in this case, but generally, you must check whether your critical points are within the interval that you're given. Okay. Now, what I need to do is, since the critical points are candidates for where an absolute min or an absolute max can occur, I must substitute these values into the original function. So if I substitute -1 for x in the original function, not the derivative, the original function, what I would get is 2 times -1 cubed, so -2, plus 21x squared. Well, -1 squared is equal to +1, so I have 21. Plus 36 times -1 is -36. So what I get is 21 minus 38, so -17. Okay. And then I also substitute in substitute x equal to -6. So I have, well, -6 cubed is equal to -216. So I have -432. And then 21 times 36, so that's 216. So times 6 again is 1,296. Okay, actually, wait. No. Oh, sorry. I'm trying to do too much math in my head. Okay, so fine. Just this once, I'll use my calculator. Okay. Well, actually, no, I don't. It is 36 times. So 36 times 20 is 720. Plus 36 more, 756. Okay. And then minus 36 times 6, so that's minus 216. Okay. So then I have 756 minus 648. So that's equal to 108. Okay. So these are values I have so far, but I don't know yet if these are the absolute max or absolute min, because you must check the endpoints of your interval, minus 7 and 7. So I will substitute these into the function as well. I think this time I really will be running for my calculator, just because powers of 7, not as easy to work with. Okay, so f of minus 7, so 7 cubed is 343. So times 2, that's minus 686, because minus 7 cubed is minus 343. And then 21 times 7 squared, so that's the same as, well, 21 is 3 times 7, so that's actually plus 3 times 7 cubed. So, okay, 1029, and then 36 times 7, but minus, okay, I guess it's time to give it a go. So 1029 minus 686 minus 252 is equal to 91. So that will not be the absolute maximum. So far, this is the largest value we found. This is the smallest we found so far, but we still have to substitute x equals 7. That will, once we have that value, then we'll know for sure. So actually, we're going to have the same numbers as before, just different signs. So we're going to have 686 plus 1029 plus 252. So let's see. So 1800 plus so 1915, 1967. So what we have to do is, once we substitute the critical values and the endpoints into the original function, then we just check to see who are the winners. Which one is largest, which one is smallest. Largest is the absolute max, smallest is the absolute min. So here we have the largest value, 1967. So at x equals 7, the y value is 1967, so that is the absolute max. And then the smallest value is this one, minus 17. Which occurs at x equal minus 1. So I get minus 1 and minus 17 for the absolute min. So check your critical points, check your endpoints. Those are all of your candidates, and see which ones give you the largest and smallest values.